I am the president of Rome Consulting. I was a pitcher for the New York Highlanders from 1903 to 1905. Then they kicked me off the roster, and I wound up pitching the rest of my career for the Louisville Colonels in the Southern Association from 1906 to 1909. There's my tobacco card. They misspelled my name, and that's been my entire life. They misspelled my name. So then I disappeared for many years, was reincarnated as an industry writer and editor from 1987 to the present. And I'm also an Infocom University instructor, and that's been from 2000 to the present. So when these guys asked me to talk a little bit about market disruption, I could hardly refuse. I think I learned a few things about displays over the years, but I want to say that if somebody calls you an expert, what an expert really is somebody that knows how much they still don't know about their subject area and how much they have to learn. So the display industry, if you're going to pick one thing in this market that has been disruptive, it would have to be the display industry. That is the poster boy for disruption. It's been disrupting the AV industry ever since the first overhead projector LCD projection panels launched. Remember those from the 1990s for about $3,000 to $6,000? The commercial LCD VGA projector sold for $9,000 to $12,000, and they had like 500 lumens of output and a nasty hotspot. First commercial DLP data projectors, that was back in '95 in Dallas at Infocom, $7,000 to $10,000. First commercial wide XGA plasma monitors, $13,000 to $20,000 in 1998. First commercial LCD monitor, doubles as a television, $17,000, was only 28 inches. So a bright portable projector was about 30 pounds, 500 lumens. A light valve, remember light valves? Light valve projector was only 2,000 lumens. We can get 2,000 lumens out of something that weighs just a few pounds on a desktop. A 50-inch wide XGA plasma monitor had a dot pitch of 1 millimeter. Keep that number in mind, 1 millimeter. Cost about $400 per diagonal inch. And we were still largely using big, expensive CRT data monitors back in 1999. I have all my shootouts from 1995 on, and went back and researched it, and I was quite surprised to see that. But, as they say in Latin, time flies. LCD projector panels basically were gone from the market by 1997. LCD projectors with wide XGA resolution, you can buy them for $600 now, 3,500 lumens. DLP projectors with Ultra HD resolution, 4K, $1,300, 2,000 lumens. Plasma's gone, buried as of 2013. LCD panels are moving to Ultra HD. You can now buy TVs. How many people here have an Ultra HD TV? Put your hand up. They get cheaper by the minute. I mean, if you stand in the store long enough, they'll keep discounting it so much, eventually they'll pay you to take it off the show floor. OLED, who has an OLED here? Anybody have an OLED TV? Not so many? They're coming into the Pro AV market. You're going to see them on the floor. I saw a couple out there already. Make sure you stop by the LG booth and see the Ocean, the Wave OLED that they have. Still expensive, $35, $50 a diagonal inch. But full HD resolution is on its way out. There's no money in it anymore. You can't make a profit making full HD panels from a manufacturing standpoint in Asia. So Ultra HD is taking over, whether you think it's a smart idea or not. LED tiles and walls, excuse me, are pressuring light valve projection, and they pitch 1 millimeter, 3,000 nits out of something with less than 1 millimeter. And now we have 8K resolution coming at Gate 2020. I'll have more on that in my class tomorrow, and it's real, and it's here. And those are all online prices, by the way. I researched from my local Staples, which, by the way, hardly even keeps projectors in stock anymore. Pretty much everything was a special order. So, just how disruptive has the display market been? Well, you could ask any of these companies. I'm going to show you a list of companies. You might recognize some of them who exhibited at the shootout from 1995 through 2000. And how many of them are still around? Some of these brands have disappeared completely. Some of these brands were bought by other brands. Some of these brands were actually being manufactured in China, and they're licensing the name to put on the particular model of projector. But that's a pretty long list and some very distinguished names on there. So they're all gone from the display industry as far as manufacturing. Now, I want to introduce you to a concept that I'm going to mention again tomorrow, the 7-year itch. We seem to cycle through resolution in our displays about every 7 years. I don't know where this rule came from. It just seems to happen that way. So if you go back to the first 720p displays, let's say around 1998, where they became mainstream, we were transitioning from CRTs. Then we transitioned from 720p to 1080p pretty much by 2012, another 7 years. 6.5 years since the first 4K Ultra HD TVs appeared, And they're cheap now, again, about $5, $6 a diagonal inch with basic high dynamic range support. LCD panel manufacturers now are ramping up 8K production. Why? Because they can't make any money making the 4K panels. They're so cheap now, you can actually lose money manufacturing them. Although anybody here that was a big fan of the Lucille Ball show, Lucy and Desi, they had that business where they said, we're losing money on every one, but we'll make it up in volume. Display Daily 2019, by 2022, 8 to 10 Gen 10.5 fabs are expected to be in production. That's an enormous piece of mother glass. That's like 11 feet by 10 feet. And the reason you make the big glass is you can get more cuts out of it at the desired size. And the desired size now is getting bigger. It's getting to be around 60 to 65 inches. So they also forecast 5.4 million 8K TVs will ship worldwide by 2022, 60% of those sales in China. And here's a little chart that shows you just how quickly they expect 8K to grow, from just a handful of units in 2018 to 5.8 million. So it's taking off. And why is it taking off? Because of price. A lot of people now buy a TV by looking at it and saying, what's the biggest screen I can afford at the most affordable price? That's what I want to take home. And that's what they're doing. So along the way, we've been blowing up a lot of business models. When the first LCD projectors sold in 1993, when they first appeared, the majority of these products and the LCD panels were sold through AV dealers. And that was great. Everybody made profit. The dealer made profit, the manufacturer made profit, reps made profit on it. But now the majority of projector sales are through distribution. There's not a lot of profit for anyone in a projector sale anymore because the cost of the hardware is relatively minimal. Projectors were built in the United States. We actually did that at one time. In Europe and in Japan. They were the focal point of many Infocom booths. They created this entire shootout that we had for many years. And now most small projectors are made in China. Many manufacturers decided, there's just no money in this, we're just going to get out altogether or concentrate on LCD panels. Well, how about the meeting room? How's it impacted that? Well, portable projectors were a godsend when we first saw them because they pushed open the doors for slide and overhead projectors and kicked them out. And those big, heavy CRT rear projection monitors, we could kick those out too. We had a new product category, the hang and bang projector. Buy a projector, put it on a mount, set up an 80-inch screen, you're done. But now, big and expensive HD, Ultra HD LCD monitors are pushing open the same exit doors and kicking the hang and bang projectors out. And so we have LCD screens 80 inches and up replacing projection screens because there's no ambient light issues. And the prices are relatively cheap for these big monitors. First generation wireless projection links designed for projectors took forever to upload. I remember visiting a manufacturer's booth to see him upload a PowerPoint from 802.11b connections, and it only took 10 minutes. We were very impressed with that. But now we have fast wireless and collaboration products make streaming even 1080p 60 video. It's a piece of cake using channel bonding, 802.11ac and AX. But don't take my word for it. This came out, Linda Norton from Pacific Media Associates. Pro AV channels of flat panel displays surged in April. Unit volume went up 100% year to year. Revenues grew at a lesser pace for the same period due to an 18% drop in average selling price. So that's the Lucille Ball model. We'll sell a ton of them and we'll make it up in volume, we hope. So April revenues for 4K Ultra HD models still represented the lion's share of the total reported flat panel display revenues. So what that basically is saying that everybody's asking for 4K. They're asking for 4K panels. And at some point, that's all that will be available. All the manufacturer will sell you is a 4K panel, an Ultra HD panel. If you don't want to use it for that, that's fine. They have upscaling engines in them, and they all work, and they'll do the job. But you won't be able to buy full HD panels because nobody wants to make them. Unit sales of flat panel displays rated for 24/7 operation doubled from April last year, but year-to-year revenues are relatively flat, reflecting the decrease in average selling prices due to heavy competition. So one manufacturer has flat panels, well, everybody has flat panels, and what are they doing? It's a race to the bottom to try to sell these things, and they keep slashing the prices on them. How about the signal interfaces? Well, remember the good old days when we had all these different analog signal interfaces with different connectors, and it was a wiring nightmare to put all this stuff together? Multi-wire analog cables were large and heavy, but now we're migrating to IT-based signal distribution and interfacing. Since we're using all digital interfaces, HDMI, DisplayPort, DVI, and SDI. An RGB HV matrix was a big, expensive piece of hardware that took up a lot of space, multiple RUs. But with AVIT, it's a piece of cake. You could do a 10 gig network switch with 40 ports, and it takes up one rack unit. How about scaling processors? Remember when these things were big bucks items? Remember line doublers, line quadruplers, scan converters? I'm really dating myself here. A line doubler, this was a hot deal back then, to go from 1575 to 31.5 scan rate, 2200 to 6500. The $6,500 ones look really good. A line quadrupler to go to 63 kilohertz ran $2,200 to $5,000. A presentation switcher scaler, these were really cream of the crop, expensive products, $15,000 to $20,000, fully loaded for these things. But now, nobody makes scan converters anymore. They don't need them. Nobody makes line doublers and line quadruplers anymore because we don't use NTSC anymore, nor do we use PAL. We've gone digital. A digital presentation switcher scaler is about $1,500 to $2,000 for a good model. That's an enormous price drop. And this is the biggest troublemaker of all. And you know what I'm talking about here. The inorganic light emitting diode. I have to distinguish that from organic light emitting diodes. Somebody said, is the differences OLEDs are better to eat or they're more friendly to the environment because they're organic? No, it doesn't work that way. Two different technologies, but this technology and all its implementations is going to turn the entire display industry on its head. A version of it is going to replace LCD and OLED for both monitors and TVs. It's going to replace projection for a lot of applications. It's definitely going to replace monitors, and eventually your televisions at home will have this technology built in. So inorganic LEDs are the biggest disruptor of all, in my opinion. This is the Godzilla of the display industry. It's going to come through and destroy everything else. It may take a while, but it'll get there. Back then, when I say then, I'm going to go back almost 20 years and say a fine pitch for an LED was 12 to 15 millimeters. That was a pretty coarse-looking display. The only place you were going to use that is either outdoors at a stadium or for digital signage on the side of a building. But now, a typical pitch for a mini LED is 0.8 millimeters to 1.8 millimeters. That's come down by a factor of 10. It's really good for close-up viewing. You just have to watch the luminance levels. Now we have a problem where you want to install these things in a room, and it has been done to replace a projection system, but you've got to throttle back on the brightness because it's too much for your eyes. They're scalable to any resolution in medium to large walls. And tomorrow, we're going to have micro-LED tiles. These are smaller than 50 micrometers. They're tiny little emitters. It requires a great deal of precision and a lot of luck to make these things and keep the yields up. And then ultimately 8K resolution and beyond in TVs, even handheld displays. You may be surprised to know that one of the big companies that's investing in micro-LED is that same company that makes the iPod, the iPad, and the MacBooks. Apple is building a prototype micro-LED manufacturing line in California to see if they can make this fly, because their goal is to start making their own displays, and all their displays will use micro-LEDs. So this is a little video I shot. I was visiting a demo room out in Irvine, California, the latest in display technology. That is a 120-inch mini LED display. The dot pitch is about 0.84 millimeters. You might recognize the manufacturer. They have another name for this. It's called The Wall. But this is showing 4K video. And I asked what the brightness was, and they said about 1,600 nits. Well, 1,600 nits in a darkened room is actually painful to watch. So you have to dial that way, way, way back, probably down to about 100 to 200 nits. But that could be your television. And by the way, in that room, 22 channels of surround sound, Dolby Atmos. Now, if you want one of these, if you're like, boy, I could get into that, it's around $400,000. So you might want to wait a little bit till they get the bugs out of it. So as we stand on the threshold of 2020, and I still have a hard time believing that that's just around the corner, displays continue to achieve higher and higher resolution. Are we going to see 10K, 12K? There's already been a 10K prototype. There's been a 15K prototype shown. LCD displays have gotten larger and less expensive. Projectors are getting squeezed by direct view displays. LCDs, having killed off plasma and having a good time laughing about it, are turning around saying, uh-oh, because LED is about ready to crush them. Inboard scaling is killing off the need for outboard scaling. Fast Wi-Fi is eliminating the need for cables in many cases. Profit margins continue to get squeezed. Again, it's really hard to make money selling this stuff. Chinese manufacturers continue to expand panel capacity. So it's really just another normal day in the world of display technology. And again, if you want to pick something out of all we're going to hear today, I'm going to say my vote is displays is the most disruptive technology of all. And that concludes my presentation.